Alright guys, so here is the review for exam 2 that's in class tomorrow. What I'm going to review in this video is just working the problems. There will be knowledge-based questions over the basics of oral doses, parenteral doses, and doses that are measured in units. So make sure that you do look at your week 2 quiz questions and also look through the week 2 slides that are posted in Canvas for those. Because there will be questions, but we're not going to review that material in this video. So, looking at example 1 here, we're caring for Mrs. Potts, and her provider writes for her to receive 500 milligrams of Augmentin PO daily for her sinus infection. This label that's right here is what we have available in our facility to use, and our question's asking us how many tablets the nurse will administer per dose. So looking at our label, we see that these are 250 milligram tablets. So we could write here so we know 250 milligram tablets. Okay. So first step with our dimensional analysis, draw our cross. Remember, our order is going to go on our left-hand side, and what we have available is going to go on our right. So our order is for 500 milligrams, and we have 250 milligram tablets available. So per one tablet, there's 250 milligrams. So our milligrams is going to cross out. We have tablets left, which is what our answer is asking us to be in. So we can multiply across the top and the bottom. So 500 divided by 250 is going to give us 2 tablets. All right, example number 2 here. We are taking care of Mr. Ryder, and his provider writes for him to receive 975 milligrams of aspirin PO 4 times a day. Again, our image right here is what we have available in our facility to use, and our question's asking us how many tablets we will administer per dose. So, looking at our label, these are 325 milligram tablets. Okay, so again, with our dimensional analysis, draw our cross first. Our order is going to go on our left, so 975 milligrams. And then what we have available, 325 milligrams, is going to go on our right-hand side. So per one tablet, there's 325 milligrams. Milligrams cross out, we have tablets left, which is what our answer is looking for, so we can multiply across the top and the bottom, which is going to give us 975 divided by 325, which is going to be 3 tablets. All right, moving on to example 3 here. So now we're taking care of Mr. Marland, and his doctor wants him to get 45 milligrams of phenobarbital PO 2 times a day. Same thing as the last 2. Our label here is what we have available in our facility to use, and we want to know how many milliliters we're going to administer per dose. So looking here, this phenobarbital elixir has a concentration of 20 milligrams per 5 milliliters. So let's write this up here so it's easier for us to see. Dimensional analysis set up per usual. Order, 45 milligrams, goes on the left. And what we have available is going to go on our right. So 5 milliliters is going to go on top. 20 is going to go on the bottom because remember they have to be diagonal to cross out. So our milligrams are diagonal and will cross out. And we have milliliters left, and our problem's asking us for our answer in milliliters. So we can go ahead and multiply across the top and the bottom. So we have 45 times 5, that's going to give us 225 divided by 20, which is going to give us 11.25. But remember, one of our rounding rules from this week is that if a number is greater, if we're giving greater than 1 milliliter of a medication, we round to the nearest tenths. So this is going to make our answer 11.3 milliliters. All right, moving on to the next one. Now we're taking care of Miss Dory, and her doctor wants her to get 60 milliequivalents of potassium chloride by mouth 3 times a day with her meals. We have a bottle of potassium chloride that has a concentration of 40 milliequivalents per 30 milliliters. And we want to know how many milliliters we will administer per dose. So we have our dimensional analysis cross here. Our order, 60 milliequivalents is going to go on the left. And we have 40 milliequivalents per 30 milliliters available. That's going to go on our right. So remember, they have to be diagonal to cross out. So 40 milliequivalents and 30 milliliters. Milliequivalents cross out because they're diagonal and they're the same. We have milliliters left, which is what our problem is asking our answer to be in. So we can multiply across the top and the bottom. So 60 times 30 is going to give us 1,800 divided by 40. And we are going to get a total of 45 milliliters as our answer. All right, so now we're taking care of Miss Merida, and her doctor wants her to get 30 milligrams of apresiline IM. We have a vial of apresiline that has a concentration of 20 milligrams per milliliter, and we want to know how many milliliters we're going to give her per dose. So draw our cross. Remember, order goes on the left, so 30 milligrams. And we have 20 milligrams per milliliter available. So our 20 milligrams is going to go on the bottom, so it'll cross out. And our 1 milliliter is going to go on top. Our milligrams are going to cross out. We have milliliters left, which is what our answer needs to be in. So we can multiply across the top and the bottom. 30 divided by 20 is going to give us 1.5 milliliters. All right, looking at our next example here, Miss Cindy is who we're taking care of, and her doctor has put an order in for her to get 3 milligrams of Dilaudid IM every 3 hours as needed for severe pain. We have ampules of Dilaudid available that has a concentration of 4 milligrams per milliliter, and we want to know how many milliliters we're going to give her per dose. So we have our dimensional analysis cross. Remember, order on the left, so 3 milligrams is going to go over here. Then we have what we have available, so 4 milligrams per milliliter. 1 milliliter is going to go on top, 4 on the bottom. Milligrams cross out. We have milliliters left, which is what our answer wants. So we can multiply across the top and the bottom. So 3 divided by 4 is going to give us 0.75 milliliters. Now, second rounding rule that we need to remember for this test is that if we're giving less than 1 milliliter of a medication, we want our answers to be rounded to the nearest hundredths. So in this case, 0.75, that already is at the hundredths, so we're just going to leave our answer as is. All right, looking at our next example, now we're taking care of Miss Rose, and her doctor wants her to get 400 milligrams of Cantrex IM every 12 hours. We have a vial of Cantrex that has a concentration of 0.5 grams per 2 milliliters, and we want to know how many milliliters the nurse is going to give per dose. So, looking at this, we have, for our order, we have 400 milligrams, and we have 0.5 grams per 2 milliliters available. So, milligrams and grams, those don't match up. So, we need to convert them. So, remember, we said it's always easier to take our order and convert to what we have available. So 400 milligrams. Okay, so we're starting here on our King Henry line, and we're trying to get to base because gram is a base. So 1, 2, 3. So we're going to move our decimal 3 places to the left. 1, 2, 3. Meaning this is going to be 0.4 grams. Okay. So on our King Henry, or on our dimensional analysis cross, our order goes on the left, which we determined was 0.4 grams. And what we have on the right is what we have available. So 2 milliliters on top, 0.5 grams on the bottom. Our grams will cancel out. We have milliliters left, which is what our answer needs to be in. So we can multiply across the top and the bottom. So 0.4 divided by 0.5. Going to give us 0.8 milliliters of this medication that we're going to administer to our patient. And looking at our last example, we're taking care of Miss Bell, and her doctor wants her to get an order for 4,000 units of heparin sub-Q every 8 hours. We have a vial of heparin available with a concentration of 5,000 units per milliliter. And we want to know how many milliliters the nurse is going to administer per dose. So, drawing our dimensional analysis. Order on the left. So, 4,000 units. And what we have available on the right. So, 1 milliliter. And 5,000 units. Units cross out. We have milliliters left, which is what our answer needs to be. So we can multiply across the top and the bottom. We have 4,000 divided by 5,000. Which is going to give us 0.8 milliliters. So that is working a problem of every type of problem that we worked in class before the summer break. So our oral doses, tablets, and liquid, our parenteral doses, and our doses that have to do with medications that are in units. So remember, your biggest rounding rules is if we're giving 1 or more milliliter of a medication, then our answer should be rounded to the nearest tenth. And if we're giving less than 1 milliliter of a medication, then our answer should be rounded to the nearest hundredths. One more type of problem that we're going to look at. We're going to ignore all of this right here. But if we have a problem that's saying that we have 17 units of insulin, or an order to give 17 units of insulin, and we have available a vial of insulin that has 100 units per 10 milliliters, or whatever the concentration is, and it's just asking us how many units we would draw up. Remember, there's no calculation that's involved. All we're going to do is just use our order is going to be our answer. Same if it says that we're going to give 10 units of a regular insulin and then 12 units of a long-acting insulin. And it's going to ask us how many we're going to give. We're just going to add those up. So 22 units. And remember that if your decoration behind your number is in units, then it has to be a whole number. Again, just remember to look over the basics of oral dosing, parenteral medications, and meds that are dosed in units from your week 2 slides, because that will be on the test as well. And then the video for reading your med labels and your reconstitution is already posted. And then also make sure to just read over the medication administration safety slides as well. That's not really material that we need to go over in a video, but you should definitely be reading it on your own. So just message me if you have any questions, and good luck tomorrow.